Hey, hi everyone. Welcome back to my YouTube channel. My name is Sunny and I am back with another important video. So guys, in this particular video, we're gonna discuss about the preference based training. In the previous video, we understood about the instruction fine tuning, and before that, we understood about the non-instruction fine tuning. Now in this video, we'll focus on the preference based learning or preference based training. I will show you all the theoretical example along with the practical. So guys, if you haven't seen with my YouTube channel, then please go and check. Here you will find out video with respect to the different concept of the generative AI. Now once you will go inside the video section, you will get all the videos over here, or else you can check out with the playlist. So here I kept the playlist regarding the different concept of the generative AI, whether it's a LLM ops or fine tuning or agentic AI or retrieval augment generation, basic RAG, advanced RAG, as well as multi-model RAG. Now guys, if you don't know, I started one end-to-end LLM fine-tuning playlist where I uploaded 15th videos so far. Now this is going to be 16th video where I am going to discuss about the preference based training. Now how many more video I will record inside this playlist? So it will be around 8 to 9 more video. Okay, so there I am going to discuss each and every framework, each and every type of model, and the different other concept of the LLM fine tuning. Then I will start with some new playlist, maybe LLM from scratch, or I will upload couple of more video with respect to the RAG and agents. So if you haven't subscribed my YouTube channel, guys, please do subscribe. And if you have any thought, anything, please write inside the comment section. Now let me show you that what all thing you're gonna learn inside this particular video, and then step by step, one by one, we'll implement all those things. So here I kept the complete points, guys. So we'll learn about the preference alignment or preference training. Then we'll understand why do we do preference alignment, means why it is required. Then we'll see the example, dataset example, like how the dataset look like. If I have to do the preference alignment, then what kind of data I will have to create. Then we'll see techniques for the preference alignment. So what all technique we have? We just know about the RLHF, that is called reinforcement learning through the human feedback. But that is not only one of the technique. We have a couple of other techniques. So definitely I will discuss onto it, and even I will show you the research paper. Then the very famous infamous technique for this preference alignment, that is called DPO training. So we'll understood about the DPO training. We'll see the mathematical formula. I'm not going to show you the complete mathematical intuition along with the derivation and all. I will just focus on the formula, and we'll discuss about that formula. Okay. Then we'll see the practical implementation with the DPO itself. So whatever model I had, means whatever model I trained in my previous class, the instruction fine-tune model, I'm going to take a same model, and on top of it I will perform the DPO, that is called direct preference optimization. Then during the practical I will show you the LoRA adapter, means how you can use the LoRA adapter. Why you should not directly implement the LoRA. Okay, if you are going to be use the already fine-tuned model. Okay, how to use the LoRA over there, definitely I'll show you. That comes under this LoRA adapter. So yes, we are going to discuss all this point throughout this tutorial. Now after this tutorial, guys, you will be like become a champion in the preference alignment, and you can basically fine tune. Okay, you can train any sort of a model on top of the preference data. Now let's start with the theory, then I will come to the practical, guys. Now here, guys, I created a step-by-step notes for all of you, so that you can refer it later and you can revise your concept. Now before starting this thing, let me show you the notes from the previous session. So for that, I have created one repository with the name of this complete LLM fine tuning. There only I am uploading all the notes and all everything. Now where you will get a link of this repository, so you will get inside the description of the video. Okay. So here I created a repository for the LLM fine tuning 14, for the 15 and 16. So the 16 basically it's a current video. Okay. Now I likewise I will create for the other basically video also. I'm getting so many requests, sir, please upload all the notes and all. So definitely I'll update this particular repository. Okay. Now guys, if you will go and check with the previous repository or with the previous notes, right? So here it is. Let me show you. So see all the files and all, everything I kept. Handwritten notes is there, IPYNB file is there, CSV file, JSON file, even the GIF file, model GIF file also I kept, right? So you can directly download it and you can start your practice. So guys, this was the handwritten notes. Now here I discuss some fundamental thing. So I discuss about the LLM training process. So the first step of the LLM training process is called the unsupervised pre-training or self-supervised training. So here we get the foundational model, okay, at this particular stage. So we are not going to perform this particular thing from our end, right? We are taking any foundational model from the Hugging Face or from any other places. Now our aim to perform the fine tuning, okay? So regarding the fine tuning, I shown you the supervised fine tuning. So I shown you two way, one with respect to the non-instruction data, and the second with respect to the instruction data. Okay, the instruction data one is specifically called the supervised fine tuning, but if we have non-instruction data, in that case also we can fine tune the model. I shown you each and everything. You can refer the previous video. Now in this video we'll discuss about the third point, okay, preference based alignment or training, right? So these are three main stage of any LLM training, right? And now we are going to discuss this third one, and after this means after this video you will find out video on top of the different framework, okay? Because in this video we'll complete the third stage, the last stage of the LLM training. Now guys, let's start with the theory of the LLM based alignment or preference based alignment or preference based training. So guys, to align or train a model with a human expectation or with a human preferred data is called preference alignment or preference training. So this particular technique was introduced by the OpenAI in Instruct GPT paper. Don't worry, in some time I will show you that particular paper, and definitely you can refer that. Now why we do it? We do it to get a safe, helpful and the honest model. Maybe you're not getting couple of things just by reading this particular definition, but you will get once I will show you the different example. So here I kept one example. Just read out this statement. So user is asking one question to the model. So the question is very simple: how do I lose my weight? Okay, how do I lose weight faster? Something like that. So I have a fine-tune model. Let's say this is the instruction fine-tune model. Now it is answering. It's a simple thing. What you have to do, you just have to stop eating, right? Just stop the eating. Give me a moment. I think now it's fine. Yeah. So just stop eating so much. Now you can see the answer is correct, but it is rude, it is dismissive, and there is no explanation. Means it is not aligned with the human expectation. If ChatGPT is giving you this kind of answer, maybe you will not be satisfied. The answer should be according to the human expectation, right? So let's say this is the output from the instruction fine-tune model. Now just look into the one more response, right? Now just by seeing this response you will be more happy. And nowadays from the ChatGPT or from any basically large language model, we are getting this kind of output because the model further have been trained on a human preference data. Okay, now just look into the another answer. Now let's suppose we have one more model which have been trained on a preference based data. So the answer is safe weight loss generally happen gradually. Okay, you can start with a balanced meal, regular movement, adequate sleep and hydration. If you have medical condition, it's best to get a personalized plan from a professional. I can help you with the simple step if you want. Now guys, just look into the difference, right, between this answer, this particular answer and this answer. So if you want to generate this kind of answer, right, so maybe you will have to take one more step with respect to your LLM training. You will have to perform the RLHF, RLAIF, that is called reinforcement learning through AI of generated feedback, or you will have to perform the DPO, that is called direct preference optimization. Now, first two technique, RLHF and RLAIF, it is based on the reinforcement learning. And the second technique, DPO, it is a simple supervised training. Okay. So yes, definitely we'll discuss. Now, here you can see in the second one, in the second output, you can see the answer is having a correct tone. It is a respectful, right? And it gives the proper explanation with the like it is a more helpful answer. Okay, it's a more human aligned answer. So that's why guys, I was saying this preference training or preference alignment is a very important part of the LLM training. Now coming to a couple of more example. So here I kept one more line. So after the preference based training, model does not just produce accurate answer, it behave according to the user preference. Okay, it behave according to the user intention. So that's a like key difference between a normal fine-tuned model or a aligned model like GPT-4, GPT-5, 5.1, 4.0, 4.1, whatever like latest and the state of art model you can see. Now why we do this preference training, guys? So this preference training we do to improve the safety and ethics of the model. We do it for generating the helpful answer, for the more polite answer. Okay, we teach the model so which can respond like a human, means which can response in whatever way the human wants. I kept one more example, maybe with that your understanding will be a bit more clear. So how I can lose 10 kg weight in 1 week? So if we have a normal trained model, so see how it is going to be generate answer. You can stop eating, drink only water, and take fat burner pills. This will reduce weight quickly. Okay, so just suppose this model basically it has not been trained on a human preferred data, right? Now here guys, you can see the another answer. Now another answer is rapid weight loss 10 kg in a week is unsafe. Okay, and it is medically harmful. A safer approach is just to lose 0.5 to 1 kg per week through balanced diet, hydration and activity. If you have urgent concern, please consult with a doctor. Now guys, tell me which answer you will refer. So you will refer this particular answer or this particular answer, or which is a more ethical, which is a more safe answer. So definitely this answer is a more safer compared to this one. So in the human preference training, in the preference alignment, basically we teach to the model to behave like this. I hope you are getting my point now. Now we'll see the different technique, what are technique we have, and we'll look into the DPO formulas and all, and then we'll go for the practical, guys. Now guys, let's see the dataset example. Let's see how the data looks like for the preference training. So here I kept the example for all the three methods. The first one is for the non-instruction fine tuning as well as the unsupervised pre-training. In both cases, the data will be the plain text. Okay. Now how the input and the output column will look like? So the output column will be the next token. Okay. And the continue word. So let's say this is my sentence. Now what is the next word of it? This is the next word. So this will be my output. Now see, this is my complete sentence. Okay, till oral. Now what is the next word? This is my next word. Now here you can see this is my complete sentence, right? Now what is the next word? This is the next word. So inside the non-instruction fine tuning or inside the unsupervised speed training, what we are doing, we are predicting a next word. So the next word will be inside the output column. Okay. Now how to decide the length of this input and output? So for every model we have one specific context length. Okay, so according to that we can decide, right? Now the second is the instruction fine tuning. Now in the instruction fine tuning we will be having 3 column or sometime you will only get 2 column. Okay, so the first column is the instruction, the second is the input, and the third is the response. In this particular format you will get a data, or else the data would be like this: input, called context, and the answer. Or the data might be like this: user and the assistant. Okay, or sometime you will see context and the response. Means The moral of the story is we will be having one input column and the corresponding output column. Okay. Then how to format this data and how to utilize it for training the model. If you want to know everything in detail, then please go and check with my previous video, right? Now, how the data look like for the preference training? That's the main agenda of this video. So inside for the preference based training, guys, you will find out three main column, right? One is the prompt, second is the chooser, and the third is the reject. Now this two is very important. Choose, right, which one is going to be select, and which one is going to be rejected. Now let me show you some real example from the Hugging Face itself. So here is the data from this Anthropic. So Anthropic has uploaded one data. Okay, the repository itself is Anthropic, and the data set is called the RLHF. Okay. Now here inside this particular data, you will find out two column only. The first is a chosen and the second is a rejected, right? Now you can see the another data. So inside, see this data basically it is available inside this ARGILLA repository, ARGILLA, right? So the data set name is Ultra Feedback Binarized Preference Clean Data. Now inside this particular data also you will find out two main column. First is the rejected, and the second column will be the chosen. Okay, along with the given prompt, right? Now here is a third example. So this is available inside this Xinlai repository. So the dataset name is math step DPO 10K. Now inside this particular repository also, inside this dataset also, you will find out two main column. The first one will be the chosen, okay, with respect to the particular prompt, and the second column will be the rejected. Okay, so see here is a rejected. So choose and reject, right? Select or reject. This will be the two main column inside any preference data set, right? Choose means which one we are going to be select, and reject means which one we are going to reject, right? I hope this thing is clear. Now let's see the technique, guys, and then what I'll do after that I'll show you the DPO formula, okay, and then we'll jump to the practical. Now guys, let's see the technique for the preference alignment. So the very infamous technique that is called RLHF, reinforcement learning through human feedback. The second technique is RLAIF, reinforcement learning through AI generated feedback. The third is DPO, direct preference optimization. Now these are the algorithm KTO, PPO, IPO. It's a reinforcement based algorithm to implement this RLHF or RLIF. In RLAIF also we use this particular algorithm. Okay, so what's the full form of this algorithm? Just for the general knowledge. So KTO is called the Kahneman-Tversky optimization. PPO stand for proximal policy optimization, and this IPO stand for implicit preference optimization. Now this is a very famous technique, guys. Even OpenAI is also revealed that they have used this particular technique initially for the reward modeling. Okay, PPO, proximal policy optimization. It is a reinforcement based technique. Okay, reinforcement, it's a like reinforcement learning algorithm. Now the technique is RLHF. What is the core idea? The core idea to train a reward model using the human feedback. Now what kind of data we were using there? Ranked responses, okay, which was ranked by the human. Example, OpenAI Instruct GPT. So this is a research paper. One model basically was released by the OpenAI. Regarding that model, I will show you the research paper. This OpenAI Instruct GPT. There also you will see the use of this RLHF technique, okay, through this PPO. The second technique is called RLAIF. This was introduced by the Anthropic. Okay, so inside the RLAIF, you will get the AI generated feedback. So human generated feedback was not very scalable idea. Means how many feedback can be annotated by the human, right? Maybe 1 lakh, 2 lakh, right? But if we have to make it scalable, then how we can do it? So there they have introduced this RLAIF, where human is not giving a preference. Actually, we are taking that particular preference from the AI itself. Okay, so this was discussed inside this research paper. I'll show you in some time. The third technique, and very popular and in demand technique right now, that is called direct optimization policy, okay, using the preference pair. The full form of it, direct preference optimization. Now guys, this is not a reinforcement based training, okay, reinforcement based learning. So here we are not going to use reinforcement learning. This is a simple supervised learning. Okay, simple supervised learning means we just have input and in the other column we will be having the output. That's it, guys. Okay, so chosen and the rejected. That's it, right? So nowadays we are using this particular technique only. Now let me show you the research paper regarding each and everything. So guys, I will attach all this research paper in the description. So this is the first one. The research paper name is Training Language Model to Follow Instruction with the Human Feedback. So just check out with this particular research paper. You will get so many detail over here. And this research paper was published by the OpenAI. It's a very good research paper on top of the RLHF. Just read the instruction at least and the couple of headings. Okay, you will understand. See here, I was saying now. They have used the PPO technique, proximal policy optimization. So initially for the RLHF, they have used the PPO technique. Okay, so just read out this research paper. Now the second one is the direct preference optimization, DPO technique. It is also very famous technique, and it was introduced by the Stanford University, right? So just look into this particular research paper. You will get the complete details. See here, this particular research was published by the Stanford University. Now here you will see the Indian, also one Indian, Archit Sharma. Now the couple of other person, right? So just see, it was released in 2024, and just read out the abstract at least. Okay, you will get the complete detail of what is a DPO and how we can implement that. Now the third technique, which is called RLAIF, right? So it was inspired from the RLHF only. The difference is human is not going to be annotate anything now. Like only AI will do that. So just check out with this particular research paper. It is a very good research paper. You will get like very good knowledge through this research paper. Okay, and this was published in 24 last year itself. It's a very latest research. Now here also like you will find out so many contributor. Okay, so Abhinav Rastogi and Sushant Prakash is one of the guy, right, who contribute inside this particular research paper, right? So just read it. You will get the complete detail of the reward modeling and the differences between the RLAIF and the RLHF. Now guys, let's look into the DPO. Okay, because see, we are not going to use the RLHF technique, RLAIF technique as of now. Maybe I'll show you in the future, but that is deprecated now. People are using DPO, which is like very simpler, okay, and simple to use. So I will show you the formula of it, formula of the DPO, and then I will go for the basically practical. Okay, so let's start with that. So guys, here is a DPO training loss intuition. So it's a loss function. So based on this loss function, my model is going to be trained. Okay. Now guys, you know about the supervised learning. So in the supervised learning, we have input, then we have a output. Okay. Now this output, basically it is called the actual output, which we generally demonstrate with the Y. And then we are going to be predict, right, something from the model that is called Y hat. So we check the differences between this Y and the Y hat, and we try to minimize. See, this differences, actually it is called the loss. Okay, and we try to minimize this particular loss, right? So that's the overall idea behind the supervised learning. If you don't know about it, you can learn about the linear regression. You can learn about the artificial neural network. Okay, there you can learn about this particular concept. Now using this is the loss function, and using this particular loss function only, we are going to train our model. Now let's try to understand this formula. Now why we are understanding that? So let's say if someone is going to ask you in an interview, right? So how did you train, how did you perform the training, this preference training, right? So you can say I perform using this DPO, and inside the DPO basically we are using this loss function to train my model. Okay, it's a supervised learning only. So inside this formula we have so many terms, but it is not very complicated. It seems complicated, but it is not. Let's try to understand it. Okay, so here you can see we have this pi theta, pi reference. So pi theta, actually it's a preference aligned model, okay, which is trained. Now this pi reference is what? This pi reference, actually it's a reference model. So it's a instruction tune model, okay, which comes before the preference alignment model. Okay, so pi theta and pi reference is clear. Now pi this y plus is what? This y plus actually prefer response, means the chosen response, okay, with respect to what? With respect to this prompt, X prompt, okay. Now here, see, this is like my reference, sorry, alignment model, okay. And here basically we are passing this preferred this is my preferred response with respect to this prompt, okay. Now here is my reference model, right, and here is what? Here is my preferred response with respect to this particular prompt, right. Now similar to that, you can see over here, so the model is there, right. Y minus means what? Y minus means rejected response with respect to this prompt, okay. I hope you understood it. Now we have a couple of more terms. So we have this sigmoid, okay. Now apart from that sigmoid, you will find out this beta, okay. And now you will find out this minus e, right. This minus e is nothing, it's a symbol, okay. Minus e means what? Expected, right. What we are expecting? We are expecting this term should be minimum, okay, and this term should be the maximum one. That's it, guys, okay. It's just a symbol, nothing else, right. Now let's try to understand one by one. I just kept I just broke everything over here. So a log pi theta, okay, y plus with respect to this x, and then pi reference, the reference model, okay, y plus with respect to this x. So what does mean? The meaning is how much more does your model prefer the chosen answer compared to the reference model, okay. So here is what? Here is my basically preferred model, and here is my reference model. So with respect to this reference model means my supervised trained model, I'm checking how this preference model is behaving, right. Now similar with respect to this rejected prompt also, okay. So the selected prompt as well as the rejected prompt. Now what we'll see the differences. So chosen improvement, okay, and the rejected improvement. So if it is going to be positive, means my model is aligning to this chosen prompt, okay, the chosen output. Now here sigmoid, what it is doing? So you know the value of the sigmoid, it is between the 0 to 1, right. So it is giving me a probability, okay, kind of probability score, right. Now here beta means what? Beta is a scaling factor. So if the beta is high, means we are enforcing model to we are enforcing model to align more to the chosen, okay. If beta is low, means the rejected one, the model is more aligning to the rejected, okay. The typical value of the beta between 0.1 to 0.5, right. And here I written the minus e meaning. What is the meaning? We want to minimize the negative, which means the maximize, we are going to be maximize the positive value. So here let's understand the meaning again. Let's take a quick revision. So this particular term with respect to the preferred response, okay, means the chosen response. So we have two model. This is my preference aligned model. This is my reference model, okay. Same with respect to the rejected response. So we are checking, right, how my, so here what we are checking, how much more does your model prefer the chosen answer compared to the reference model, okay. So we are going to be compare with respect to this reference model. Then what we are doing, we are going to be scale it, right, and then we are going to be check the probability, right. We are just going to be compress the entire value between 0 to 1. That's it, guys, nothing else, okay. And if the answer is positive, okay, we are getting more positive in like multiple epoch, we are training for the multiple epochs, and this result, the loss result is going to be positive, means my model is aligning to the chosen responses. That's it, guys. So I hope you understood it. Later on in a dedicated video, I will show you the derivation of it. Now one more thing, guys, before coming to the practical. So I kept a couple of more points with respect to this Instruct GPT paper. So this paper, just now I shown you this paper, right? Training language model to follow instruction with the human feedback. So this is the Instruct GPT research paper. Now regarding that, I kept a couple of point, few summarization, right? So here human was labeling the data, right? So whatever response we were generating to the model, human was ranking those things. Now using the PPO, basically we are going to be find out which is like more helpful, right? So this was a chat GPT style alignment, so which initially was done by the OpenAI, okay. Now on what all prompt, basically we are finding out, we were generating the output. So on top of the API user prompt means whatever user was writing, okay, through the API, okay, some question answer, right, sorry, some public questions, basically those prompt was taken, and on top of that they have generated an answer from generated a multiple answer, and then human ranked those answer, right. So this is like some extra information, you can confirm it from this particular research paper. It is very good like to understand the to understand how they have initiated the RLHF technique. Okay. Now let's move to the practical, guys, and after that basically I'll show you the comparison between all the model. Okay, and one more important concept with respect to the LoRA adapter. So here only we'll cover that part. So guys, we had the base model. If you remember, then I took the base model. This base model is also called the foundation model. Now here is my foundation model, my base model. So I fine-tuned this model on top of the PDF data, and after that I got this particular model, non-instruction model. Now why we have done this thing? So that my model can understand the domain specific language, domain specific vocabulary. Okay. Then I want to teach my model proper conversation. So what I did, I fine-tuned my model on top of the input and output data. Okay, means on instruction data. Okay, so what I got the instruction model. Now guys, I want to be train my model. Again, I fine-tune my model on human feedback. Okay, so after that what I will get the preferenced model. So this is the aim for this particular video. I hope you got it. Now for that what I'm going to do, I'm going to load all the libraries. So I'm going to load the auto tokenizer, auto causal for LM, training argument trainer, LoRA config, get pep model task type, and load dataset. So I will teach you the meaning of each and every class, each and every function which I'm loading over here. So yeah, this is done. Now here is my base model. Now why I've written this base model here, so that I can load the tokenizer. Okay, because this tokenizer I will be using. So yes, the tokenizer is here, tokenizer is ready, and I think I already explained you the meaning of this pet token and this end of the sentence token. You can check out with the previous session itself. You will get the entire detail. Now what I'm doing, guys, so I'm going to unzip my previous model, this tiny llama instruction.zip model. Now why I'm doing it? Because I'm using a same model throughout this journey. Means I was having the foundation model, then the same model I train on the PDF data, I got this model. Then same model I train on the instruction data, I got this model. The same model I'm going to train on the human feedback data, and I will get my final preference model. Okay. So here what I'm doing, like when I trained my model in the previous class, so I saved that as a zip file. So this zip file is also available in the GitHub. You can check it out directly. Okay, or if you will train it, if you will train the model from scratch, okay, over here using this particular notebook, this IP1B file. So at the end you will get this particular model itself, this tiny llama hyphen instruction. Okay, then you can convert into the zip and you can save it anywhere. That's it. So guys, I have a model. I have already uploaded this particular model over here. You can see. Now let me unzip it. So after the unzipping it, what I will get this checkpoint 3. Okay. So this is my train checkpoint, instruction checkpoint. Let me load it. Let me take it inside the variable. Now I'm loading it. Okay, and I'm testing whether everything is working fine or not. So for that I kept one prompt. So explain the AI in improving the process of the drug discovery and the development in the pharmaceutical industry. So this is my prompt. Now this first what I'll do, I will convert into the tokens. Okay, and I'm mapping to my GPU. Now I will pass this token to this method. So instruction model dot generate. I'm passing the token. Along with that, I'm passing some other parameter like how many tokens I want in the final output, some other parameter with respect to some tweak, some creativity in the output. Okay. Now repetition penalty means the token should not be repeat. So regarding that, we can mention this particular score 1.1, and I think this score we can like write up to 2. You can check out the complete detail of it. Okay. So yeah, this is also one of the parameter. It will stop the redundancy of the token. Okay. So we'll get output. Let's see what output I'll be getting over here. So before the class, right before the class, I was testing, and I already run it. Okay, if you are running it first time, then it might take some time. So here is the output. So explain how intervene, this is the question. Now regarding that, see the answer is being generated. You can get some better answer. If you have much data, then definitely you will get some good answer, aligned answer itself. Now here this answer is also aligned, and it is with respect to my question. Now I want to perform the preference based learning. So for that guys, we are going to use this TRL module. So under this TRL module only, you will get all the this preference tuning based classes like DPO, like RLHF, like RLAIF. Okay, so different classes you will get under this particular module only. So let me install it. So the command is very simple: pip install -u TRL. You will get the latest version. Now after that, if you want to load a quantized model, so there is one more package, bits and bytes. So let me get this package also. Okay. Now guys, after executing this two command, pip install -u TRL and pip install -u bits and bytes, you always restart the kernel. Otherwise, you might get an error that this package is not visible. Okay, so let it install, and after completing this one, what I'll do, I'll restart the kernel. Okay, this is done. Now what I'm doing, I'm checking with the runtime. Now here you can see the restart session. Just click on this restart session. Okay, the kernel will automatically restart. See, right hand side, it is getting restarted. Now load this step again. Okay, because after restarting, this will be gone. So yeah, everything is fine. Now guys, this module is installed, this bits and bytes is also installed. Now let's try to perform the DPO training. Now here I want to teach you one very important concept of the LoRA guys. It is very important. I think most of the beginner and even the experienced person does this kind of mistake. So I don't want to repeat that mistake over here. Okay, and even I rectified that mistake in the previous solution also, and definitely I will highlight those part. So for this preference based learning, I'm using this DPO trainer. Okay, rest of the module will be same, which I already imported in the previous cell. So from the TRL itself, we are going to import this DPO trainer. If you are doing RLHF, or if you are using some if you are doing the RLHF, RLAIF, right? So from the TRL itself, you will be loading everything. Okay, so we are having this DPO trainer. Now what I'll do, so here is my base model guys. Then this is my instruction checkpoint, right? So my model is available over here inside this particular checkpoint, the instruction model. Now after that guys, you can see, so we are going to be load the data set. So here the data set plays a very important role. I will show you what kind of data I'm using and how I created that. Then I'm loading the tokenizer, and after that you can see we are assigning this end of the token to the padding token. Okay, so let me check what is happening, whether everything is ready or not. So yes, this is running, because see guys, we have a limited memory, so we might get some issue with respect to the memory and RAM. So better don't execute everything again and again, the harder step, otherwise you might face a issue in the collab. So yes, it is working fine. My model is still giving me a reply. Now TRL, with respect to the TRL in bits and bytes, I reloaded the environment. Now first of all, let me import all this statement. Okay, so after that guys, what I'll do, I'll take the base model, I'll take the instruction point. Now here is my data set. So how the data set look like? So I already kept the data set over here, pharma preference underscore data.csv. This data could be available in CSV as well as in the JSON format. So I basically kept the CSV as of now, but you can load the same from the JSON file also. So how the data look like? See, here is the data. So inside the data, you will get the prompt. You will get the chosen one column. Okay, the second third column will be the rejected. So we are giving a prompt to the model, then we are generating a multiple answer. Now which answer is being selected and which answer is being rejected, so that particular information we have kept over here. I think you got this point. Now whenever we are passing a prompt to the model, okay, so model will generate something, so that this can be wrong, or this like can be the correct one. So initially I shown you like how the human annotate this entire labels and all, whether I have to choose it or reject it. Later on we have automated this task also, okay, on a very high scale. So this task have been automated by the LLM only. So we are giving certain instruction to the LLM, and based on that it is able to find out which is the chosen one and which is a rejected one. I hope you got it. So this type of data we required for what? For the training. Now here guys, see, we are loading a base model. Okay, we are having the instruction checkpoint. Now we have a data set also. Now what I'm doing, I'm going to be perform the tokenization. So from the auto tokenizer, I am loading my base model. Okay, so it will come inside this particular variable, tokenizer variable. Then what I will do guys, so after that the same thing, you will have to assign the pad token. You will have to assign the EOS token, end of the sentence token, as a pad token, right? Now here we need to understand one very important concept. So we're talking about the PEFT module. Okay, so PEFT is giving us two different methods. So see, PEFT, we have a PEFT, right? So from the PEFT we are importing this PEFT model, and from the PEFT itself we are importing this get PEFT model. So guys, we need to understand the differences, okay, between this PEFT and get PEFT model, because it is very much important. So guys, I capped the complete intuition over my blackboard. So let's understand it one by one. So what we are doing, guys, as we know, we are having base model, then we are training it for the non-instruction model, then instruction model, then preference model. Okay. Now, how we are doing this training? So we have a base model. Now we are doing the LoRa based training, and we are getting a non-instruction model. Then again we have a non-instruction model, and we are adding the LoRa adapter, LoRa layer, and we are getting an instruction model. Now here again we have an instruction model, okay, and we are adding the LoRa. We are means we will try to do the same one. We will add the LoRa, okay, and then we'll get the preference model. But guys, to be honest, this is not a good thing. This is not a good practice, and no one is following that. Okay. Now see over here what we are trying to do. We have a base model. We are connecting with our LoRa, okay, the LoRa adapter. Then base model LoRa. Then again in the instruction tuning, again one more LoRa. Then we have base model LoRa, and then again one more LoRa would be there if we are following the same step over here. So stack of the LoRa layer is not good. Stack of LoRa is not a good idea, guys, and that's a step I followed in my previous tutorial, right? And you were able to see the responses. It was not quite good. Why? Because the LoRa layer was getting stuck. Now if you don't know about the LoRa, don't worry. In the upcoming video I will explain you with complete detail, with a complete mathematical derivation and all. Okay, so don't worry about the LoRa, but let me give you the quick definition of it, what it is. So here I written, LoRa is not a full layer. Okay, it's not a complete model, it's just a delta patch. Okay, so delta patch cannot be stacked, they must be merged before the next training. So what is this delta patch? This delta patch you can think in such a way. We have a weight, old weight. To this old weight, we are going to be attach some small matrix of weight, okay, and we'll get the new weight, okay, new weight, WEIGHT. Okay, so we are having the old weight. We are going to be attach it with the like some small weights. Okay, and now this particular patch, the small patch. Okay, it is only called the delta patch. Okay, so my LoRa is nothing. It's a small patch. It's a small weight which we are going to be attached on top of my old layers. Okay, and then what I will get? I will get my new weights. So here is a proper mechanism for it. Means this particular weight is being trained. This is going to be freeze. This is going to be freeze. This particular weight is going to be trained. Now after the training, it will be merged into the old weights. So that's a whole sort of a idea of the LoRa. We'll discuss it in a more detail in the upcoming session. So this delta W is called the patch, and this is only called the delta patch. Okay, and this is my LoRa weight. Now we no need to stack the LoRa weights. Okay, see, this is my W, the original weight. If we are doing a non-instructional training on the safe model, we'll get this W1, del W1. Then if we are doing the instruction tuning on top of the same model, then we are going to be attached this del W2. Then for the preference learning, again del W3. So we should not take this particular step, and this was a mistake even which I made in the previous solution. Okay, I will give you the correct approach, which approach basically you can follow for the LoRa. Okay, if you are using a same model again and again for the training, that how to use LoRa efficiently, it's very 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 important. Now what is the disadvantage of this thing? So the disadvantage is loss will be unstable, model will hallucinate, tuning will not be good, and the quality will degrade. Why it will degrade? Because loss will be unstable. We won't be able to figure out the loss properly. right? If we are having this kind of weight, if we are going to be c- uh, if we are going to be create a stack of the LoRa, right? So what is the solution of it? So to use the LoRa in an efficient way, that's the solution. Let me show you how. So let's discuss how we can use LoRa in a better way. So if you will check PEFT guys, so this PEFT is giving me two methods. One is get PEFT model. The second is PEFT model from pre-train. Okay. So when we have to use this get PEFT model and when we have to use this particular method, so definitely we'll be talking about it. Now here we have a get PEFT model. So it creates a new LoRa during the training. Means the new LoRa patch, the delta patch which I showed you. Now this PEFT model dot from pre-train. Now what it does, so it load a already trained LoRa model, okay, for the inference or for the further training, right? So we are going to use this particular method for loading the previous LoRa weights for the for loading the previous trained LoRa model, and then on top of it only we are going to perform the fine tuning, okay? But the way is going to be a little different. See over here, observe over here what we are doing. So we have a LoRa configuration. So here I'm writing task type is going to be causal LM, that is for the next token prediction, okay, for the language modeling. Then there's the rank of the LoRa. R is representing the rank. LoRa alpha is one of the parameter. LoRa dropout, okay, one of the parameter. It's a hyperparameter. You can keep any sort of a value of it just to test your output. Means just to check what impact it is having on the final output. Then which like module we are targeting in the attention layer. So we are mentioning that part over here, and bias is equal to none. So this is what this one LoRa configuration. Now what we were doing guys in the previous class, and even if I didn't find out the current approach, then what we would be doing, let me explain you that first, okay? Then we'll come to the correct approach. So we are having this method get pet model. So we are simply passing this instruction model, okay, and then we are passing this LoRa configuration. So we were thinking, okay, now we will get a model which we can tune further. But guys, this is a wrong approach. Now what we are doing over here, we are having the instruction model, and on top of it we are going to be connect the LoRa stack, okay? So the stack of the LoRa again and again, okay, on a like same model which we are training on a different phases to append the LoRa, okay, to create a LoRa stack. It is not a good practice, okay? So what is the correct approach? Let me tell you that. So first what we'll do guys, we will load the base model. So here is my base model, okay? I'm not going to take this particular step. I'm just going to be comment it out. Means directly I'm not going to be take a model. Means directly, see here I'm giving my instruction model which I loaded earlier from the zip, okay, and here I'm attaching the LoRa stack, and then I'm getting this PEFT model LoRa, but I'm not going to perform this thing because this is not a correct approach. So what I will do guys, so first I will load my base model, okay? Inside this particular variable I was having the base model. So let me show you this base model which was there. So here is the base model, okay? So we are able to load the base model. I got it inside this variable. Now in the second step, what I will do, using this method pept model dot from pre-train, okay, I'm passing this model, my base model, and I'm passing my instruction checkpoint, means this instruction model, okay, this particular model. Now after that what I will do, so after loading this thing I will get my model, okay? So this model, this base model, basically it is connecting to the instruction checkpoint, right? Now what I will do, I will merge it, okay, merge and unload the weight. Means I was having the base model, on top of it I will keep the LoRa weights, I will merge both weight, okay, and after that I will get my model. So here is my model. Now what I will do, on top of this model only I will connect the LoRa stack. So here is get pept model, I am passing my model, and then I am passing the LoRa configuration, right? So just check out all the thing. It is very much important guys, very important. See over here. So what I'm trying to say, just focus over here just for one more minute, okay guys? So we are having the base model, we perform the non-instruction fine tuning, okay, after the LoRa, and we got the non-instruction model. Then again we were having the instruction data, we performed the instruction tuning, and we got the instruction model, okay? Now this two thing, this non-instruction model I did with the LoRa, instruction fine tuning, again I have loaded this non-instruction model and I attached with the LoRa, and then again I perform the training. And then now the same thing I'm going to do with the preference model also. But guys, this is the wrong technique, okay? to create a LoRa stack like this, which I explain over here, it is not a good thing. Why? Because we might get this kind of issues. So what is the best approach? The best approach is, first guys, see, here is my basically this instruction model, this one. This is my instruction model, checkpoint 3, okay, which I already trained, right? So what I'm doing over here, see, just focus for one more minute. So here basically what we have a LoRa configuration, that is fine. Now I'm not going to be like pass this instruction model, and we are going to be create a LoRa again on top of it, and then I'm calling it as my preference model, which I'm going to tune further. No. So here I'm taking a base model, so I'm loading it. Now after that we are going to be connected to the instruction checkpoint, okay. Now after that I'm calling this method merge and unload. So merge and unload, what it will do, it will merge model, my freeze model, as well as the instruction LoRa, okay. Then on top of it I will create the LoRa patch. Now this particular patch is going to be trained, okay. Now this particular patch is going to be trained. So this model which I got, a pep preference model LoRa, okay. After, see, this is my method get pep model, I'm passing my model, I'm passing my LoRa configuration. Now I will get the delta patch, okay. I will get the LoRa patch delta, the delta, right? Now that particular so I'm keeping it over here inside this particular variable. Now I will be training this model on top of my preference data set, right? So here I created one table also, non-instruction base LoRa, it is correct, instruction base plus merge, okay, stage 1 LoRa, then new LoRa, this is the correct approach. Directly LoRa on LoRa, it is not a correct approach. Now preference base, so base model, then merge stage 2 LoRa, then plus new LoRa, this is the correct approach. LoRa on LoRa on LoRa, this is not a correct approach. I think now you got the complete LoRa. So let's train my model. So here I am going to be write bits and biases disable true, and don't want to be capture any sort of a matrix. So here guys, I'm going to be define my DPO trainer from the TRL. So TRL is giving me these classes, DPO trainer and the DPO config. So yeah, this is fine. Now what I will do, I will create a object of this class DPO basically config. Now here I'm writing a directory, in which directory, in whatever directory I want to be save my model. Here I have a learning rate, and then I have train batches, okay, gradient accumulation is step, right? At how many steps we are going to be accumulate the gradient value. Number of training epoch, how many, for how many epoch you want to be running, beta value, report to none, I don't want to report on any basically platform, okay. So here also I did that same thing, and you can mention this parameter also. Logging directory none, as of now I don't want to be log anything. Loss type is sigmoid, okay, will collect the will calculate the loss with this particular function. Remove unused column, okay, false, I'm not going to be remove any column as of now. I know guys, you get the little difficulty while you go through with this all this particular parameter. We have so many parameter, if you will hover the mouse over here, you will get maybe, so we have so many parameter over here, maybe hundreds of parameters. So don't worry guys, it is my responsibility to teach you everything. I will create a proper video on top of each and every parameter of these classes, okay, it is my promise. So let me take this DPO argument. Now here I am defining the DPO trainer, there I am passing my model, okay, which the model basically, here you can see this particular model, this one, preference model LoRa. Now how I got this model, so I was having the base model, okay, on top of it I appended this instruction checkpoint, I merged both the weights. Now on top of this particular model, on top of this particular weights, okay, this particular model, I attach the this like LoRa patch, okay, and then I got this model, and further I'm going to train it now, okay. Now here is my model and reference model. I'm not passing any reference model, otherwise I can pass the reference model over here, that is also one of the facility, okay. Argument, so DPO argument, this particular argument which I defined over here. Now after that guys, training data set, so data set which I loaded, okay, from the CSV, this particular CSV, this I shown you, okay, only 5 data points, you can keep as many as. Then here processing class, that is tokenizer, okay. So if I run this trainer, so see, it is saying preference model is not defined. So let me run it first. Okay, I got this one, this is fine, this is perfect. DPO argument is also fine, DPO trainer is also perfect. Now trainer.train. Now guys, this is my final step for training the model. So trainer.train, and yes, my model is getting trained. it will take time, guys, if we have a huge model and a very huge data set. As of now, it is a quick because we have a very small model, not very small, guys. We have a small model with a very small data set, and my epoch is one, and I kept the parameter in such a way it won't take much time, just to show you, guys, just to show you. But in a real time, you will be doing it with a huge amount of data, so it will take maybe days. Okay. Now here it is just testing. So testing with a non-instruction model. Okay, so here is my question. Explain how metformin works in the human body and why some research believe it could have benefits beyond diabetes treatment. So guys, if I will test this question with my different model. Okay, so let me test for two model, instruction and the preference. You can test from your end this one, non-instruction one. Okay, so this is my question, guys. Now what I'm doing, so here is my testing with the instruction fine-tuned model. So this was my checkpoint. Okay, instruction one. Now I'm going to be load this model. See, instruction model would be here. I'm going to tokenize this question. Okay, and then I'm going to generate a output, and then here will be my final output. So let's see what will be my final output, guys. We'll compare the output. Okay, we'll compare the output of the instruction model as well as the preference model. Let's see the difference, whether we are getting some like good terminology, something like that, right? So it is saying question is not defined. Let me execute it. Okay, so here we have a question. Now model is there, input tokenizer is ready. Okay, now here is my output, and then I will be getting the final output. So let it complete, and yeah, I will get the final output, guys. Just a second, it takes some time. Yeah, so this is the output. Now see, guys, explain how metformin this is that. Now see, this is the answer. Crohn's disease, inflammation, bowel disease. I don't know this is correct or not. You should check it out, right? But guys, there's some redundancy in the output because I did the mistake in the previous training. Okay, I will come to that just a second. Now here is my model path. This is my LoRA mod. This one preference based model. Okay, see here I saved that model inside this folder, tiny llama preference alignment. See, there's a folder. Okay, now what I'm doing, I'm going to be load my model path is here. I'm going to be load my model. Now I'm going to be connect with the CUDA, okay, to the GPU. Then guys, I'm going to be like tokenize the question. Okay, I will be getting inside the input. Now this input I'm passing to my model. Okay, preference alignment model for the final generation. Now let's see the final output. So let's see what I will be getting over here. So it takes time. The output generation might take time. Let it complete. It depends on the infra also. If you have a good GPU, good infra. Now see, guys, explain how metformin works in a human body. This is that. Now see, metformin, common diabetes drug, two type. So see, guys, you can clearly see the difference. So difference between this normal like output from the instruction tuning and the output from the after output after the alignment. Okay, so guys, you can make a difference over here. Means like you have trained a model on top of the instruction data. That is fine, that is completely fine, I'm not denying that. But if you want to more enhance on the human preferences, you can take one more step, like this chat gpt have done. If you're training your model from scratch, this will be very helpful. Now I was saying, guys, I have done one mistake. So the mistake basically I rectified over here. If you will go and check with the instruction tuning, so I written that code over here. You can now execute this file, and in whatever way I have explained you this LoRa stack over here. Okay, so see, this I'm not going to be follow now. Means I will not append LoRa. First I will merge the weight, and then only I will append the LoRa patch. Okay, so I kept the code over here. Let me show you where it is. This one. Now let's okay, I think it will be the below one. So see, guys, this one. Okay, I kept the complete code. You can go through with it, you can run it, and then you can train your model. So fine, guys, this is it for this particular video. In the next video I will come up with some different framework, okay, to teach you this fine tuning. Yeah, so thank you, guys, thank you for watching it. If you haven't subscribed my YouTube channel, please subscribe. This kind of content takes very much effort, guys, to research and all, and then record. So please respect for all those things, and subscribe the channel, because see, guys, it is free for you, I know, but it is very important for me. Okay, your subscribe, your like, your support, everything. So fine, I'll see you in the next video. Thank you. Bye bye, take care.